At the Hanover main plant, the home of Volkswagen commercial vehicles, the first stage is the press shop. The process starts with steel coils. In the vast press hall, overhead cranes move these heavy rolls into position with smooth, controlled precision. Now the material enters the heart of the shop, the servo press line. In Hanover, this line works with 6 presses and automated handling technology. Blanks are fed into the system, aligned, and transferred from one forming stage to the next in a tightly synchronized sequence. With each stroke, flat metal gains more shape, more depth, and more definition, becoming recognizable body panels for the vehicles built here. Behind the glass, the process is monitored in real time. Operators watch the line through control screens while the machinery continues its rhythm below. Precision here is not only about force, but also about timing, repeatability, and constant supervision. The line is designed to maintain both speed and consistent quality as panel after panel moves forward. At the end of the forming process, the finished parts leave the press line and move into the next handling stage. Robotic systems and automated transfer equipment position them carefully, while other stations prepare them for stacking and transport. What began as a simple steel coil is now a finished pressed component, ready for body construction. Finally, the panels are stored in transport racks and collected for the next step of production. Forklifts move the containers through the hall, carrying side structures and other large stamped parts onward to body assembly. Here in Hanover, the unmistakable shape of a Volkswagen van begins. After the press shop, the stamped parts enter body construction at Volkswagen Hanover plant. The first operation in this passage is the lower body. The floor structure sits in a carrier and is fixed to exact datum points. Next, ABB robots begin the first joining cycle. The side structure moves into its own fixture. Intersections, reinforcements, and outer panels are held in a large tilted tool, while robots work along the flanges and connection points. Here, the robot is not welding, it is dispensing. A nozzle follows the joint path and lays down a controlled bead of body shop material along the flange. ABB describes this as a bonding and sealing process in which the robot, nozzle, and dosing unit control the path, quantity, and shape of the material. That material can serve as adhesive or sealant. Its purpose is to form a sealed joint between parts, block moisture, help prevent corrosion, and reduce noise and vibration in the finished body. After dispensing, a heavy-duty robot grips the large side assembly and rotates it into the next position. Now comes the framing stage. The side structure is aligned to the floor and the rest of the shell in one common geometry. Large fixtures hold the body at many points, while more robots close in from the sides and above. At this point, the body stops being a set of subassemblies and becomes one body in white. The following stations are dense, multi-robot joining cells. The shell is held in large clamp frames, while additional spot welds are added around the roof frame, side openings, and structural joints. This is the stage that locks in stiffness and dimensional stability. The welding is no longer about creating one part from loose panels. It is about securing the final geometry of the complete shell. Once those cells are complete, the body leaves the main robot area on the transfer system. It passes through enclosed conveyor and buffer sections with the heavy structural joining finished. The shell now has its full van form. Floor, side body, roof structure, and openings are all established. The body in white now enters a manual fitting zone. First, the front fenders are staged in sequence racks. The operator positions the panel at the front side of the body and uses an adjustable support fixture to hold its shape and height. The next operation is the side sliding door. Its weight is carried by a guided installation manipulator. Once the door is brought into position, the operator aligns it to the guide and hinge mounting areas and secures the connections while the manipulator keeps the load neutral. The final step is functional adjustment. The sliding door is moved through its travel and checked at the closing position. Here, the operator verifies running smoothness, latch engagement, and flushness to the adjacent body panels. The paint shop. Here, robotic applicators lay down the first sprayed coating layer over the outer shell and into the body openings. This stage is primer surfacer. Its job is to create an even substrate for the later color coat. The robots follow programmed paths along edges, bends, apertures, and large panel surfaces, building a uniform film before the body moves on to the next coating step. In the paint shop, the body enters the seam sealing station. Here, Dur robots apply a precisely metered bead of seam sealer along critical joints between body panels. The first robot works inside the body shell. Its applicator reaches through the side opening and follows the inner seams with a programmed path. The nozzle lays down a continuous bead along overlaps, weld lines, corners, and stamped bends. Next, the operation moves to the outer seams. Another Dur robot traces the upper side joints and roof side seam areas where outer panels meet. These exposed seam lines must be sealed cleanly and evenly before the body continues deeper into the paint shop. By the end of this station, the Volkswagen van body has been sealed at its key inner and outer seam lines. The shell is now protected at critical joints and is ready for the next paint shop process. In the paint shop, the body passes through a manual seam sealing station. Workers touch up joints that are difficult to seal automatically, using brushes and hand applicators to coat roof side seams, door apertures, and other exposed panel transitions. At one opening, a sealing insert is fitted before the surrounding joint is finished. Then a handgun lays a fresh bead along an outer seam, and the material is brushed and tooled over a masked area to form the final seam profile. Technicians fit anti-vibration pads on the door and floor, then press body plugs into stamped openings. Before the two-tone paint stage, the body enters manual masking. Workers first define the paint break line by hand, laying masking tape exactly along the roof edge, pillars, apertures, and panel transitions that must stay protected. In tighter areas, the tape is trimmed and pressed into the contours so the separation line stays sharp during spraying. Then, the roof and upper body are covered with masking film, which is unfolded across the shell and fixed in place with more tape along the prepared edges. This masking operation isolates the surfaces for the second body color and prevents overspray on panels that have already received their previous coating. In the next paint stage, the masked body enters the spray booth for the base coat. Dur robots guide their rotary atomizers along the front corners, side panels, and aperture edges, building the yellow color coat in controlled passes. The aim here is even film build and full coverage on every exposed outer surface. After spraying, the body leaves the booth and the process shifts to paint line handling. And the finished bodies continue on their skid conveyor toward the next stage of the paint shop, where the freshly applied coating will be flashed off and cured. Final assembly begins with the painted body shell entering the trim line. Then comes the main front cabin insulation piece. Workers install a large molded inner dash insulator at the front of the body, in the area later covered by the instrument panel. At the start of trim assembly, the front door is taken off again. A guided handling manipulator carries the closure while the operator releases it and moves it clear of the body opening. This temporary door-off step gives better access to the side aperture and front cabin area for interior work. Inside the shell, technicians continue fitting parts around the bulkhead and side structure. At the following station, small interior fittings are installed from line-side bins before assembly moves on. The van body enters a glazing station. A robot with vacuum grippers picks up a large black glazed roof module and rotates it into installation position above the roof opening. A second handling frame takes over the part and lowers it with controlled, even motion into the prepared aperture. Here, the module has to meet the roof opening precisely along its entire perimeter. By the end of this step, the body has received its large roof glazing element. Next comes one of the key trim installation operations, cockpit fitting. A pre-assembled instrument panel module arrives on an automated installation manipulator. There is no operator guiding it step by step here. The handling system moves the cockpit module independently, brings it to the front body opening, and aligns it with the vehicle at the correct height and angle. Then the module advances into the cabin in a controlled path. The system positions it against its mounting points on the front body structure, where the instrument panel will later be secured in its final location. At the next station, the same automated installation process is repeated on the following body. This is a high-precision assembly step. The cockpit module has to match the body opening, the cross-car mounting points, and the later fit of adjacent trim parts. The powertrain assembly begins with a finished module carrier arriving at the station on an automated transport platform. The first manual operation focuses on a routed line set at the upper side of the assembly. A worker positions the part by hand, aligns it with its fixing points, and presses it into the surrounding brackets and supports. This is careful placement work. The line has to follow its exact path across the structure so it will not chafe, twist, or interfere with later components. The next process takes place at a dedicated preparation fixture. Here, another worker lays a prefabricated cable and line harness into a shaped carrier. The branch lengths are spread out, oriented, and seated into their guides one by one. Protective sleeves, clips, and attachment points are arranged in their final order before installation. This step is about routing discipline. The harness has to leave the fixture already organized, with the branches separated and the fastening points accessible. Once the harness is prepared, the module enters an automated cell. An ABB robot takes over. The robot grips a large support frame that carries the prepared harness and its attached lines. A following module arrives and stops at the next station, where manual finishing resumes. Now attention shifts to the upper side of the suspension assembly. A worker uses a suspended power tool at the top of the spring damper unit. The tool is brought down vertically onto the upper fastening point and held there through the tightening cycle. This is a controlled fastening step. The upper mount has to be secured with the correct tool engagement and stable axial force while the module remains fixed in the carrier. Then, two workers continue on the same assembly. At the top side of the drive module, they handle a large routed harness section with multiple branches. An ABB robot works above the joined electric drive assembly and battery module. Its multi-spindle fastening head lowers onto the unit and tightens several screw connections at the same time. This is a synchronized fastening operation. The robot fixes the drivetrain module to the battery module in one automated cycle, with all fastening points engaged together instead of one by one. Manual assembly then begins on the upper side of the unit. Two workers stand at opposite sides of the carrier and prepare the next operations around the drive assembly and the electrical hardware mounted above the battery. One worker uses a suspended vertical power tool on an upper fastening point. The tool is brought down in line with the joint and held steady through the tightening cycle. At the next workstation, more topside assembly follows. A worker uses a cordless power tool on smaller fastening points while handling the orange high-voltage cable set. These cables are lifted, routed across the assembly, and placed into their prescribed path. The branches are seated in guides and support points, and the connector ends are brought to their mating locations on the electrical unit. The process finishes with detailed cable routing and connection work around the top of the assembled battery and drive module. Volkswagen builds the ID Buzz at its main plant there on the MEB platform. The electric drive system modules supplied for the ID Buzz include the battery system and the axles. Body shell arriving on its overhead carrier. It is still an empty shell at this stage. The front end is open, the wheelhouses are empty, and the side openings are unobstructed. The carrier moves the body into the upper level of the marriage line and brings it into position above the joining station. The shell advances slowly until it is centered over the platform below. Its orange transfer frame holds it rigidly from above, while the line positions it over the lower assembly. Below, the lower module is already prepared. The flat battery housing is mounted in a carrier together with the axle and suspension assemblies. Spring damper units, brake discs, and the main underfloor structure are already in place. The flat battery housing moves up into the space between the sills and underfloor. The wheelhouse area settles around the suspension and brake assembly already standing on the lower carrier. The body and the lower module are brought together with very little visible clearance, which is exactly the point of this station. Precise vertical joining of two large assemblies. Once the shell has been seated onto the lower module, the married assembly continues forward through the line. The same operation is then shown again with other bodies at the same stage. A second painted shell arrives above another prepared lower module. Again, the overhead carrier holds the body while the battery and chassis assembly waits below. The line repeats the same logic: position, align, lower, and seat. The final bodies leave the marriage area, still carried by the upper frame, but now with the running gear and underfloor battery module united with the shell. This is the decisive transition in electric vehicle assembly, the point where the painted body becomes a rolling ID Buzz structure, ready for the stations that follow. At the front of the ID Buzz, assembly begins with thermal system hardware. A worker positions a compact high-voltage front-end module in the short nose section. The unit is seated on its mounting points, then joined to the surrounding rigid aluminum lines and connection to electrically powered front-end system. On the MEB platform, Volkswagen packages auxiliary units in this front compartment, so this station prepares the thermal and service hardware before the larger front-end assembly is installed. At the front of the body, manual preparation comes. A worker uses a power tool on the lower front structure, securing the mounting points that will receive the front bumper reinforcement assembly. At the same time, the surrounding front-end hardware is checked and cleared for the next step. Then, the body moves into an automated fitting station. A large handling and fastening unit brings in the black front bumper reinforcement assembly and aligns it with the front structure. After the machine retracts, manual finishing follows. A worker checks the side attachment area and secures the remaining fasteners. The ID Buzz body arrives at the headlight mounting area and surrounding support brackets. Workers position and tighten the fastening points around the lamp apertures. then continue across the upper front carrier between the two light units. This is detailed fitting work. The headlamp housings have to sit at the correct depth and angle before the remaining front end parts can be secured. The left and right lamp units are then fixed more precisely along their upper and inner mounting points. A second worker continues inside the central front opening, tightening the front carrier and adjacent brackets, while the lower front structure remains accessible. The front end is still open at this stage, so the lamp housings, support points, and cable paths can be reached directly. After the mechanical installation, the lighting system is energized for a function check. The white light signature, the horizontal light strip between the headlamps, and the amber signal element are illuminated in sequence. Volkswagen says the ID Buzz uses all LED front lighting, with IQ dot light available on the model range. With the lights operating, final tightening and alignment continue around the upper front panel. This leaves the front carrier, brackets, and headlamp units installed and ready for the next front-end assembly steps. For the ID Buzz, the front bumper is installed as a complete pre-assembled front-end trim module. The painted bumper cover already carries its lower insert. Two operators position the part simultaneously to control three critical interfaces: the upper mounting line, the side transition to the fenders, and the lower locating area. The bumper is first seated on its guides, then held under light preload while the fit is matched to the surrounding body surfaces. At the rear of the ID Buzz body, interior work starts before the closure is fitted. The process then moves to the tailgate station. A large installation fixture brings the glazed tailgate assembly to the body and holds it in exact alignment at the rear opening. The tailgate has to meet its hinge points and sit correctly in the opening before the fixture releases it. Inside the body, upper rear opening hardware is then tightened by hand with a cordless power tool. With the inner panel installed, the tailgate is lowered and checked in the closed position. This stage starts with complete wheel and tire assemblies moving in on a roller conveyor. Each wheel arrives already mounted on its rim and is fed to the robot cell in a fixed orientation. A handling robot then takes over the wheel supply step. The gripper lifts one wheel from the conveyor, rotates it into mounting position, and brings it toward the hub. The robot holds the wheel square to the hub face and centers it on the mounting plane. This is the key locating step. The wheel has to sit correctly against the hub before the fastening tool can engage. Once the wheel is seated, a robot with a multi-spindle tightening head runs the tightening cycle automatically. This is not single-point fastening. Several wheel fasteners are tightened in one synchronized operation while the wheel is held against the hub. The same process is then repeated on another body. The wheel installation stage is complete, and the ID Buzz moves on with its running gear fully fitted. The cars continuing along the assembly line on lift platforms. Final inspection and finish. The first check is a body gap measurement at the rear side opening. The process then moves inside the front cabin. A worker checks the fit of the trim at the A-pillar, roof liner, and upper windshield area. In the passenger area, the rear seat is checked next. The luggage compartment is then equipped with a coiled cable set, which is placed into the rear load floor area. With that done, attention returns to surface finish. A worker wipes and checks the side glass area, then continues to the front end, where the painted nose panel, emblem area, headlamp surrounds, and leading body edges are cleaned and inspected by hand. Completed Volkswagen ID Buzz vehicles moving forward through the inspection lane in different exterior colors, ready for the following to deliver to dealerships. Thanks for watching. Stay with us in the world of machines. Subscribe to Cars Boom on YouTube now.